Hello, and welcome to another chemistry topic together. Go ahead and start setting up your focus notes today. Our topic you can see is called limiting reactant. And then fill in whatever date it is that you're taking these notes. The point of this topic is to make another connection between DA and moles and chemistry stuff, and then stoichiometry, this new idea. So we're going to be focusing on something called the limiting reactant. And the essential question we'll answer during today's notes are, how do I determine the amount of product in a reaction based on the limiting reactant? Okay, so you can maybe start even predicting what this limiting reactant has to do with something with predicting products and reactions, and we'll get into it. To get you thinking about limiting reactant, I want you to do this silly little like opener or like bell ringer kind of. All right, so you go home or you're done with your school and you're already at home, and you really want a PB&J sandwich. So you go to the kitchen and check out your supplies. You have one jar of grape jelly, pretty full, a partial loaf of bread. It's got 9 slices in it. And then 4 of those like peanut butter packets that, they have at some restaurants or different, travel places. So if these are your ingredients available to you, how many PB&J sandwiches can you make that look like this? They have to have 2 pieces of bread, some jelly, and some peanut butter. All right. So now think about that. Pause the video if you need to. How many PB&J sandwiches can you make? Okay, so there might be a variety of answers. Some of you might have said I can make 4 because I have 1, 2, 3, 4 packets of peanut butter. And then if I have 2 pieces of bread each, I would use up 8 of my slices of bread, all of my peanut butter. I'd have 1 piece of bread left over and a whole bunch of jelly. But if I don't have any more peanut butter, I can't make a PB&J sandwich. Or some of you might have said, I can make 1 sandwich because I need a lot of peanut butter and there's not a lot in there. So I would use all that peanut butter on 1 sandwich. I'd use 2 pieces of bread, some jelly. And so I'd have, 7 pieces of bread left, a whole bunch of jelly, but again, I'd be done with my bread or peanut butter. So the idea here is that even though you've got a whole bunch of bread and a whole thing of jelly, you run out of something and that stops your production of the sandwiches. So even though you might have had extra bread or extra jelly, if you run out of peanut butter, you can't make a peanut butter and jelly sandwich. That idea of how much stuff do I have and what can I make from it, even though that sounds like, just kind of normal stuff you do all day, that is stoichiometry. And running out of something is the new idea today called limiting reactants. So just like that sandwich example, the idea here is that it's the ratio between what you're making and what do you have available. So we already talked about this. So maybe you said you can only make 4 sandwiches because after that you would run out of bread because you would only have 1 piece of bread left and you can't make that full sandwich with only 1 piece of bread left. Or again, you could have been the peanut butter example too. So the limiting reactant is the reactant that gets used up first. So it could have been the bread in this example. It could have been the peanut butter. Maybe this is, when you're trying to like set the table and you're like, oh man, I can only invite 5 people because I only have 5 plates, right? So that would be your limiting reactant. Well, in the chemistry world, whatever reactant you run out of, it stops the reaction because you ran out of one of your ingredients. So back to the sandwich thing. So even if you had extra bread or extra jelly, if you run out of peanut butter, you can't make a peanut butter sandwich. So in a chemistry reaction, even if you have a bunch of one of your reactants left over, or excess, we call that, if you run out of something, you can't make any more product. So the whole reaction stops. And that's an idea we hadn't really talked about before. Usually we just think about mixing stuff together and seeing if something happens. But now we're going to talk about how much of stuff do you have and how much reactant do you need to make some amount of product. That's all stoichiometry, right? But the whole point is that when the limiting reactant is gone, the reaction stops and you can't make any more of your product because you ran out of one piece of the ingredients or the reactants. Here's another visual example, like hot dogs, right? So like if you have a whole bunch of hot dogs and a certain number of buns, even if you only have 1, 2, 3, 4 buns, you can only make 4 hot dogs and buns, even if you have an extra hot dog, right? So we would think that is your excess. This is theoretically how much you should make. This is your limiting reactant or reagent. It's a vocab word that means the same thing as reactant. So there's another visual. So what does an LR problem look like? Well, remember one of our big things about stoich is that you always start with a what? Yeah, a balanced equation. So POCl3 plus 3 moles of water produces 1 phosphoric acid mole, and 3 moles of HCl. Okay, so there's a balanced equation. So I might ask you a question like this. How many grams of H3PO4 can be produced from 225 grams of POCl3 and 125 grams of water? So I know how much of this I measured out. I know how much of this I measured out. I poured them together. Reaction happens. How much of this can I make? Well, kind of like the sandwich and the hot dog examples, it depends on how much of this I use up and how much of this I use up. Whichever one runs out first will stop my reaction and will determine how much product I can make. So, to do this problem, maybe what you're noticing is, well, wait a second, there's two givens. We've never had that before. So, how do I start this problem if there's two givens? Well, the two givens is your hint that this is a limiting reactant problem. We've got to do two problems and figure out which one of these reactants is going to run out first. That will tell me the answer to this question. Let's do this problem together. Okay, so here was the important pieces of information: balanced equation, the two givens, and the question, how many grams of H3PO4? So what we're going to do is we're going to do a stoic problem from grams of POCl3 to grams of H3PO4. And then we're going to do another stoic problem starting with grams of water to grams of H3PO4. So start with a given. I'm just going to go in order. Let's start with 225 grams of POCl3. I'm trying to get to grams of H3PO4. This is how I know it's a stoic problem. Every stoic problem has the switchover step because I'm switching from POCl3 to H3PO4, which I can only do if I'm in moles. So my first step is to get from grams of POCl3 to moles of POCl3. So phosphorus is 30.97, oxygen is 16, chlorine is 35.45, and I have 3 of those. Add all that up. This is your review of molar mass of compounds, 153.32 grams per mole. Review of DA. I'm starting with grams on top, so I need grams on the bottom here, equal to 1 mole. Grams will cancel. Now I'm at moles of POCl3, so now I can do my switchover step. That's a review of one of the big things about stoic. I go from POCl3 to H3PO4 because that's the chemical the problem is asking for. So I set it up. I need moles of POCl3 to cancel, so that's going to go on the bottom, and there's just one of them. But there's always also just one of H3PO4. It's a 1-to-1 ratio, but I need to show this step to show what happens to POCl3 and where did H3PO4 come from. Moles of POCl3 go away. I'm at moles of H3PO4, but the problem was asking for grams of H3PO4. All right, so I have H3, so 1.01 times 3. Phosphorus, 30.97. Oxygen is 16 times 4 because it's H3PO4. Add all of that up. This is molar mass of a compound, 98.00. Even though it's exact, keep those because we need those for sig figs. Grams per mole. Well, this time I want moles to cancel. So moles goes on the bottom, 98.0800 grams on top. Moles cancels. I'm at grams of H3PO4. Whew, that is what the problem was asking for. Multiply every number on the top, divide every number on the bottom. Calculator gives you this answer. We got to think sig figs because we have to think like a scientist. This has 3 sig figs. This has 5. This has 4. These are not measured numbers, so those don't count for sig figs. So I can keep 3. 1, 2, 3. I look at this number for rounding, which it does. So my answer is 144 grams of H3PO4. Well, if this had been a couple days ago, we would have stopped. There's my answer. But here's the problem. This is the answer for grams of H3PO4 if I use up all of my POCl3. But I don't know if I use up all of my POCl3. What if I use up all of my water? So I have to do another stoic problem starting with the other given. But the good news is some of the steps we'll be able to use this number again. We don't have to refigure it out. So yeah, we have to do another stoic problem, but the more stoic we do, the better we get at it, and it goes more efficiently. So I've met grams of water, but the problem is asking for grams of H3PO4. So I need to be able to switch over from water to H3PO4, but I can only do the switchover step if I'm in moles. So my first step is grams to moles. H2, 1.01 times 2 plus 16. H2O, add it all up, 18.02 grams per mole. Look, review DA. Grams is on the top here, so it needs to be on the bottom here so that it will cancel. So grams cancels. I'm at moles of water. Now that I'm at moles of water, I can go from moles of water to moles of H3PO4. Switch over step from the balanced equation. So I set up my problem so that moles of water cancels. Looking at my balanced equation, there's 3 moles of water for every 1 mole of H3PO4. Moles of water now cancels. I'm at moles of H3PO4. The problem wants grams of H3PO4. But again, use this work you just did in the first problem, same thing, but now we still are doing the exact same thing. Put moles of H3PO4 on the bottom, 98.00 grams of H3PO4 on the top. Moles of H3PO4 cancels. I'm at grams of H3PO4. Whew, we did another stoich problem. Multiply every number on the top, divide every number on the bottom. The calculator says this is the answer. Sure, that's the random math answer, but let's turn it into science. 3 sig figs here, 4 sig figs here, 4 sig fig here. These are not measured numbers, so there's no sig figs with them. They're just exact numbers, so I can keep 3. 1, 2, 3. I look at this number for rounding, which it does, so this rounds up to 227 grams of H3PO4. All right. So what's the new thing from today? Well, it's this idea of limiting reactant. One of these two things runs out first, and then the reaction stops. So think about it. I have a number of 144 and a number of 227. Which number do you think we keep? Think. We keep the smaller answer. Why? Because when I made 144 grams of H3PO4, the reaction stopped because I used up this given. So I couldn't make any more. So I could never make 227 grams. It was not possible. I didn't have enough POCl3 to make this much H3PO4 because when I made 144 grams of H3PO4, the reaction stopped. That means POCl3 is your LR, limiting reactant. So this is called the excess reactant, meaning I had a bunch of extra water. Great. So I could never make, not possible at all, 227 grams of H3PO4. So my answer of how many grams of H3PO4 are made is 144 grams of H3PO4. Now, technically, this is still just theoretical because I'm just doing it on math, but this is not even possible. This is my theoretical answer of how many grams of H3PO4 could be made from 225 grams of POCl3. Okay, so the limiting reactant is the one that runs out first. How do we know it runs out first? Because it makes the smaller amount of product. Those are the steps of limiting reactant problem. So let's just go through what we did. We use both givens and we calculate the amount of product produced. Whichever reactant makes the least amount of product or the smaller amount is your LR. So notice the reactant that makes the smaller amount is your LR. The LR determines the theoretical amount of product. It's not actual, right? Because we didn't really do it. It's just a hypothesis. It's on paper, on math. So the LR tells you the theoretical amount of the product. And then the reactant that makes more product is the excess. So that 227 grams of H3PO4, that told us, the higher amount tells us that water was the excess reactant. And that amount of product never happens. Why not? Because we ran out of the limiting reactant before I could ever make that amount of product. So that kind of reviews the steps of what we just did. However, there's one little follow-up question. Which reactant is in excess and by how much? Well, we already know from the problem, we knew that the LR was POCl3, which means water was in excess. But how much? Start with the LR given, calculated the needed amount of the other reactant. Let's do this together. So 225 grams of POCl3, that was my LR. And I want to calculate how much of the other reactant, which is water, how much water did I actually need? So I'm going to go from grams of POCl3 to grams of water, the other reactant, and then we'll do one little step at the end. Okay. So I had my grams of POCl3. So I had this from my previous work, 153.32 grams for every 1 mole of POCl3. I have to get to moles so I can do the switchover steps to switch over to water. All right, so I set that up so that moles of POCl3 cancels. I look back at my balanced equation. There was 1 mole of POCl3 for every 3 moles of water. This is the switchover step. It comes from the balanced equation. And again, why am I going to water? Because I'm answering this question. Which reactant is in excess and by how much? Which means I need to know how much water am I really using in this LR problem. All right, moles of POCl3 goes away. I'm at moles of water. All right, but I need to get to grams of water so that I can compare it to how much water I actually had. So moles of water goes away. I'm at grams of water. So then now I can multiply all the numbers on the top, divide all the numbers on the bottom. This is the amount of water needed. Okay, so then to figure out how much water was in excess, oh, sorry, let me do sig figs quick first. I have 3 sig figs here, 5 here, 4 here. So I can keep 1, 2, 3 sig figs. I look at this number for rounding, which it does not. So then I can keep 79.3 grams of water needed. Okay, now here's the last little piece, subtraction. Subtract the amount that we had of water and the amount that we needed to get the amount that is excess. So remember, from the given problem, I have 125 grams of water, but I only need 79.3 grams of water. So how much is excess? Subtract those two, 45.7. But remember our subtraction rules. I can't have more decimals than are in my starting numbers. So this is going to round up to 46. So I have 46 grams of water that was excess. All right, why is that useful? Well, if I was using a reactant that was really expensive or really dangerous, why would I measure out 125 grams if I only needed 79.3? So if I have 46 extra, why would I want to do that? It could be wasteful, it could be dangerous. And so that might be why I would care about this little follow-up question. So it's another stoic problem. Start with your LR given, switch over to grams of your other reactant so you can compare your have and your need to see how much was really excess. All right, so that's just kind of a follow-up question we could be asked related to LR problems. All right, for your summary today, I want you to do this critter diagram. This reviews all of the steps that we just did to solve the LR question. So you start with your two givens, then think about what did we convert it to, amount of what? Then between those two numbers, we decided how much was what made. What do we call this? It was a vocab word, starts with a T. Look back in your notes. And then between these two, we use the what amount. Now we can identify the blank blank. This is our topic for today. And then the follow-up question, start with the blank blank. It's the same as this. What's our topic? To figure out excess reactant. And then what did we use to get how much excess? Starts with an S. It was the last thing we did on the previous slide for math. So this reviews the steps, and this critter diagram will maybe this visual will help you when you're trying to do LR problems on your own, help you remember how to do those problems. All right, that brings us to the end of this second day of Unit 5. Here's your to-do list. Go back and finish any COSTA questions. Sorry, we didn't do any COSTA questions yet, so not just finish them, you have to do all of them. And then go back and do this critter diagram as your summary for today. You can either put it at the bottom of today's notes or on your output page right next to it if it doesn't fit. And then, did you already turn in the STOIC intro assignment? Go back and finish that, get help as needed with it, and then you can start the LR practice. If you did these notes on the day they were assigned, you still have like 3 or 4 days before this assignment is due, so you can come to our next Zoom to get help on this before it's due, or use office hours if you're seeing this on a school day. Okay. You could also do some of the unit practice problems, 19 through 24, that are related to today's new notes on LR. The answers are posted. Check your answer. See if you're getting them right. If not, you know to ask for help. And if you are getting them right, it confirms you understood the new information today. All right. So whenever day you're watching this, the next time I will see you depends on when Depending on what day you're watching this, it depends on when I will see you next. So I just wish you in general, see you at our next Zoom. Thanks for your focus today, learning more about LR and stoichiometry. Remember to get help as needed. See you next time.